So today we are going to be graphing rational functions by finding a bunch of pieces and information about the rational function and then graphing it. So the first step we want to do when graphing a rational function is to find the domain. So given the function x minus 1 over x squared minus 4, let's go ahead and find the domain of this function. And remember from last time, domain comes from your denominator. So on a rational function, we're going to take this denominator and set it equal to 0. We'll just move the 4 over and then square root both sides. And you're going to get x equals plus or minus 2. But we know this can't happen because if x is positive 2 or negative 2, the denominator would become 0. So here's our domain. X can equal positive 2, x can equal negative 2. And even if you wanted it in interval, it'd be negative infinity to negative 2, union, negative 2 to 2, union, 2 to infinity. Okay, so first step is always find domain. Next, we are going to factor and simplify the function if possible. So we look at the original function, r of x equals x minus 1 over x squared minus 4. And we see that you can factor the denominator. What does the denominator factor to?
X plus 2, x minus 2.
There you go. So we factor and then we see if we can simplify. But when I say simplify, I mean, can we cancel any terms out? And here, nothing cancels out, right? But we could factor the denominator. Okay. So find domain, factor and simplify, find the intercepts and determine the behavior of r of x of our function at any x-intercept. Okay. So first thing we're going to do is find the x-intercepts, where we set the rational function equal to 0. So here's a neat little trick to save you some time. Domain and vertical asymptotes come from your denominator. X-intercepts come from your numerator. So when you set this rational function equal to 0, all we really have to do is set the numerator equal to 0 and solve for x. So we'll get x minus 1 equal to 0, and we'll get x equals 1. Here's my x-intercept at 1, 0. Okay. Now we said determine the behavior of the function at the x-intercept. So what that means is we want to know what is the multiplicity, what is the characteristic of the graph going to do at this x-intercept. So we look at the multiplicity and we determine whether it will cross or touch the x-axis. So this x minus 1 has a multiplicity of
0.
Well, how many times does it show up?
Oh, 1.
1. So this has a multiplicity of 1, which means when we graph it at this x-intercept, we will cross. That's the behavior. Okay. So now let's go ahead and find the y-intercept. Y-intercept, we let x equal 0, and we'll plug 0 into the function. And normally for this one, it's easier to choose the unfactored form, just a little bit faster. So we'll just have 0 minus 1 over 0 squared minus 4, and you'll get negative 1 over negative 4, which gives me 1/4. So there's our y-intercept. at 0 and 1/4. Okay. Before I keep going, any questions so far? Oops. We found domain. We factored and tried to simplify. Nothing canceled out. Then we find the x-intercepts. We determine their behavior, the graph's behavior at the x-intercept. And then we find the y-intercept. Next, we move on to the vertical asymptotes. Find the vertical asymptote and determine the behavior of our function at each vertical asymptote. So that, again, is going to come down to the characteristics. What is the multiplicity? So we learned multiplicities of vertical asymptotes on Monday. Remember, if you have an odd multiplicity, then the graph will head up to infinity, and the other part of the graph will head towards negative infinity. If you have even multiplicity, you had both tails head up towards infinity, or both tails head towards negative infinity. And now, again, the easy money part, if you have your domain, you have your vertical asymptotes. So what are my vertical asymptotes going to be? What's my domain?
X can't equal 2 or -2.
There you go. So that means my vertical asymptotes are x equals
2 and -2.
2 and -2. Good. And now, how many times, what is the multiplicity of each of these asymptotes?
1.
1. Good. Because again, if you look at the factored form, 2 and -2 only show up
once.
So this would have a multiplicity of 1. And this would have a multiplicity of 1. Okay. So the behavior of our function at each vertical asymptote. So what we're going to say is that as x approaches positive or -2, so as x approaches our vertical asymptotes, r of x will approach either positive or negative infinity. Because since these asymptotes have an odd multiplicity, this means as we approach the vertical asymptote, one tail of the function is going to go to infinity, and another tail is going to go to negative infinity. So we learned that last time. Everybody good with that?
Yes.
Okay. All right. So, and those arrows mean approach. So as x approaches positive or -2, r of x, your y values will either approach positive or negative infinity. Okay. Next is find the horizontal or oblique asymptote. Oh boy. So now we must remember our rules of horizontal asymptotes. Well, remember those rules go with the exponents of the numerator and the denominator. So if we look back at our function, what is the degree of the numerator? What is the largest exponent of the numerator?
Cassie said 1 in the chat.
1. Oh yeah, sorry. I need to look at my chat. There we go. 1. And what is the degree of my denominator?
2.
2. So the degree of the numerator is smaller than the degree of the denominator. This means we have a rule number. So degree of the numerator is 1. Degree of the denominator is 2. Numerator is less than denominator. This means we have a rule number 1, where my horizontal asymptote is y equals what number? Zero. Good. 0. There it is. Remember those rules, guys. Reference them if you have your notes with you. If you're on a computer, you have the link to my OneNote as well. So reference those rules. Okay. So the next part of this problem says, find the points of intersection. So what we want to know is, does my function intersect the horizontal asymptote? And remember, horizontal asymptotes can be intersected. Vertical asymptotes cannot. So we want to know, does the function intersect the horizontal asymptote? And if you ever intersect with the function, this means that you share a point, which means that at this point, both functions are equivalent. So to find a point of intersection, you are going to take your horizontal asymptote and set it equal, to your function and solve for x. Okay, well, the value of our horizontal asymptote is 0, and our function is x minus 1 over x squared minus 4. And now all we have to do here is solve for x, which means I need to get rid of this denominator. So I'm going to take this denominator and multiply it to the left side. Well, what's 0 times x squared minus 4 going to be? Zero times anything is
0.
0.
0. So you'll get 0 equals x minus 1. And then solve for x. And we're going to get x equals
1.
1. Good. So we're going to get x equals 1. This means that the horizontal asymptote and our function will intersect when x is equal to 1. So I guess to put that in words, our function intersects the horizontal asymptote at x equals 1 or the point 1, 0. Okay. Well, this kind of makes sense because what's our x-intercept?
One, 0.
Our x-intercept is 1, 0, right? So if I were to plot that already, it'd be here on the x-axis. What's our horizontal asymptote? The horizontal asymptote is y equals 0, right?
1 to 0.
So this means that y equals 0 is what type of line? Vertical or horizontal?
Horizontal.
Horizontal. So it would look something like this. Which means, does that x-intercept intersect the horizontal asymptote?
No, because it's on it.
Well, if it's on it, then it definitely
And it definitely does, yes.
intersects it. There you go. All right, I'll leave those there. We're filling these in. All right. And I guess while I'm at it, I can put our vertical asymptotes at 2 and -2. Let me do that. We'll graph as we go. Why not? So this is, let me see, 0, 1, 2, -1, -2. And my vertical asymptotes are in the name vertical. That's x equals 2. Okay. Cool. Oh, and I can plot our y-intercept too. It's at 0 1/4. Oh boy. So this will be 1 1/4 is basically going to be right there. Okay. So I've plotted everything we've found so far. I plotted the x-intercept, y-intercept, vertical asymptotes, horizontal asymptote. We can see that the graph intersects the horizontal asymptote. So this means that we have just a little bit more work to do. So now in step F, use the zeros or the roots or the intercepts of the numerator and the denominator to create intervals. So what we're going to do is create a number line, or a sign chart is what it's called. We're going to take all the x values we have found, plot them on the sign chart, and then we're going to create intervals, and we're going to pick test numbers in between each interval. And this is going to tell us where the graph is above the x-axis and where the graph is below the x-axis. So here's how we're going to start this. All right, here's my number line. -infinity to infinity. And then the x values we have found, we'll start with our domain, are at -2 and 2. And then the other x value we have found is just our x-intercept, which happens to be 1. So we're plotting all the x values we have found. Okay. So now let me zoom in a little more. There we go. So the next step is to create intervals. We have basically broken up the number line with all the x values we have found. So here we have -infinity to -2, -2 to 1, 1 to 2, and 2 to infinity. These are the intervals of my number line. And these are also intervals that represent our graph above. Okay, so the next thing we're going to do is pick test numbers. And we're going to pick a test number in between each interval. And then we're going to take that test number and plug it into the original function. Okay, so somebody give me a test number from -infinity to -2.
1.
In that interval. In -infinity to -2.
Ethan said -1 in chat.
Has to be in the interval.
You're going to the left. What's something to the
Going
left of -2?
more negative.
-3.
There you go. -3 fits in this interval. So this would be where -3 is. Okay. And then give me a test number from -2 to 1 in between these two numbers. Now we're just scared to pick numbers.
Yeah, 0.
0. There you go. All right, there's 2. And before I move on, I'm going to rewrite this as r of -3 and r of 0, but we'll come back to that in a second. I just want my last two test numbers. Give me a number between 1 and 2.
1.5.
1.5. And then give me a number between 2 and infinity.
3.
3. There you go. Okay. So there's our test numbers. And again, we're doing this because we want to know where is this function above the x-axis and below the x-axis. So we're going to take these numbers and plug them into the original function, where Desmos is going to help us out. All right. So our original function is, I'm going to type it in, x minus 1 over x squared minus 4. And then I'm going to use that table feature. And I'm going to plug in our test numbers here, starting with -3 and 0. So -3 and 0. So we see that when I plug in -3, I get -0.8. And then when I plug in 0, I get 0.25. All right. Now, let's plug in our other test numbers, and I'll tell you what these mean. Now we have 1.5 and 3. And 1.5, I get -0.29. And then at 3, I get 0.4. Okay. Back to the notes. And now, let's look at the output for our first test number. So we're looking at the output for the first test number. So just look at the sign for now. We only care about the sign right now. This means that no matter what test number I pick on the interval -infinity to -2, the y values will always come out positive or negative.
Negative.
Negative. Good. So no matter what test number you pick, the y values will always be negative. This means that we are below the x-axis. Okay. Now look at the next output. From on the interval -2 to 1, no matter what number you pick, your y values will always be what?
Positive.
Positive. Good. They'll always be positive, which means we are above. And then look at the next test number. This says that on the interval 1 to 2, no matter what number you pick in between there, the output will always be
Negative.
negative. And then from 2 to infinity, no matter what number you pick, the output will always be
Positive.
positive. There you go. Okay. So positive means we are above. Negative means we are below the x-axis. Okay. Any questions on this process? All right. So the cool part about F is not only did it tell us where we were above and below the x-axis, it also gave us points of the function. So we now have 4 points that we can plot. Our points are going to be -3 and -0.8, 0 and 0.25, 1.5 and -0.9, 3 and 0.4. Which means we can now move on to step G and plot these points and then graph the function using this sign chart. So let's go ahead and do that. Let me copy and paste these points up here. Let's see. Maybe I just copy and paste the sign chart too. Why not? I'll just move all of this up there. We'll say copy. There we go. All right, so now we're coming up here. And I'm going to paste this guy right there. Paste. There we go. Move, move, move. One moment. There we go. That should work. Okay, perfect. Okay, so now let's go ahead and plot our first point. -3 and -0.8. So using red, let's stay with red or pink, whatever color this is. All right, -3 and -0.8. That's going to be somewhere down there. I'll just plot it there. This is just a sketch. Now, look at your sign chart. It says from -infinity to -2, we are below the x-axis. This means that from this point, we can draw that part of the function because everything down here is below the x-axis, which means from this point, I'll follow my vertical asymptote down and I'll follow my horizontal asymptote out to the left. Okay. And then from -2 to 1, we have our next point at 0 and 0.25, which happens to be our y-intercept. So this says from -2 to 1, we are above the x-axis, which means from this point, we're going to follow my vertical asymptote up. Okay. A -2 to 1, right? So I'll connect to my x-intercept there. Okay. And then the next point we plot is 1.5 and negative 0.30 or 0.29. So that's going to be probably in there somewhere. And on that interval, 1 to 2, we are below. So just follow your vertical asymptote down. Okay. And then the very last point, 3 and 0.4. That's going to be somewhere around there. It says from 2 to infinity, we are above the x-axis. So from this point, follow your vertical asymptote up and follow your horizontal asymptote out and to the right. And there it is, guys. That's how you graph a rational function. Any questions on that process? It's a lot of work. Yeah, sure, right? But it's everything we've learned so far. We know how to find domain. We know how to factor. We know how to find intercepts. We know about multiplicities of intercepts and asymptotes. We now have to apply the rules of horizontal asymptotes. Now we find a point of intersection. We create a sign chart. I think we created sign charts in like 4.5 or something like that. And then we graph it. So yes, all of this work is exactly what I want to see when you do your homework and your exams. Do not leave anything out. Okay. But any questions on this one before moving on? Everybody good? What's up?
Oh, no, sorry, I was thinking, but I don't have a question.
Okay. All right then. Number 2. Let's do it all over again. Okay. Number 2. Given 2x squared minus 5x plus 2 over x squared minus 4, find the domain. Hey, it's just like the last one. Our domain will take x squared minus 4, set it equal to 0, move the 4 over, square root both sides, and we get x cannot equal plus or minus 2. There's our domain. Okay, and of course, negative infinity to negative 2, negative 2 to 2, and 2 to infinity. All right. Next is factor and simplify. I'll rewrite the function 2x squared minus 5x plus 2 over x squared minus 4. Does that numerator factor? So this is minus plus, which means we're going to be minus minus, which means what are the only factors of 2?
1 and 2.
1 and 2. So this is going to give me 2x and maybe plus a number and x minus a number. Well,
No, it's
what?
should be negative, negative, shouldn't it? 2x
Oh,
minus.
sorry, yeah, not plus. Minus, minus, good. And what are the only factors of this 2?
1 and 2.
1 and 2. Where should I place them?
Should be 2x minus 1, x minus 2.
Good. And does the denominator factor?
Yes, it does. X plus 2, x minus 2.
Plus 2, x minus 2, which means we have factored, and now can we simplify?
Yes, we can take out the x minus 2's as 1s. So
And we get a brand new function, 2x minus 1 over x plus 2. And this is the function we are going to be working with. Okay. So next is find the intercepts, determine behavior. So first up is our intercept. We let r of x equals 0. But remember the trick. Domain comes from denominator. X-intercepts come from your numerator. So you just take 2x minus 1, set it equal to 0. 2x equals 1, and x will equal 1/2. We get the point 1/2 and 0. Okay. Now, what is the multiplicity of our x-intercept? How many times does it show up?
1.
1, which means our function will cross at this x-intercept. Okay. So we got intercept, x-intercept, behavior out of the way. Next is the y-intercept, where you let x equal 0, and we'll have r of 0 equal to, and we're using the new function, 2 times 0 minus 1 over 0 plus 2, we get negative 1/2. So 0 and negative 1/2 is my y-intercept. All right, Joel. Any questions so far? Repetition is key, right? We just follow the same steps. All right. Next is finding our vertical asymptotes. So again, if you have your domain, you have your vertical asymptotes. So what are my vertical asymptotes going to be?
X equals 2, negative 2.
Good. But now we have a problem. Look back at step B. Did we cancel a part of the denominator out?
Yes.
Yes. This means that which one of these equations is no longer a vertical asymptote?
2.
Good. X equals 2 is now a hole in the graph. And x equals negative 2 remains my vertical asymptote. And for this one, we still have to find the behavior of it. So how many times does negative 2 show up?
Multiplicity of 1, so
Multiplicity of 1. So that means that
1 time.
as x approaches negative 2, r of x will approach positive or negative infinity. Okay. Now we actually have one more step to do, because since x equals 2 is a hole in the graph, we need to find the actual point of that hole in the graph. So we're going to take 2 and plug it in to our function. The new function, of course. So this one will say plug into r of x. So you'll get r of 2, which will give me 2 times 2 minus 1 over 2 plus 2. And this will give us 3/4. Okay. So this means that the hole is located at 2 3/4. All right. Next is the horizontal or oblique asymptote. So let's go ahead and look at the reduced function. So I'll rewrite it down here. Our new function is r of x equals 2x minus 1 over x plus 2. What is the degree of the numerator?
Should be 1,
One.
Yeah, 1.
What's the degree of the denominator?
also
One.
1.
Also 1. So n is 1, m is 1, which means these are both equal, which means we have a rule number
Rule number 2, yeah.
2, where we get a horizontal asymptote of the leading coefficients over each other. Well, what's my horizontal asymptote going to be? Y equals 2. There we go. Okay. And then last is points of intersection. Once again, we want to know, does the horizontal asymptote intercept the function? So we take the horizontal asymptote and set it equal to our function. The value of our horizontal asymptote is 2. Our function is 2x minus 1 over x minus 2, or x plus 2. Okay. So now we solve for x, and we multiply this x plus 2 to the left side. And we'll get 2 times x plus 2 equal to 2x minus 1. You'll get 2x plus 4 equal to 2x minus 1. And if we solve for x, what's going to happen to your x's? They're going to what? Are they going to cancel? And leave us with 4 equals -1? Is that a true statement?
No.
No. So this means that since that is not a true statement, we do not intersect. Okay. Let's go ahead and plot everything we have so far before making that sign chart. So first up is my x-intercept and my y-intercept at 1/2 and -1/2. So let's go ahead and do that. So this is going to be 0, 1, 2, 3, -1, -2, -3, and then let's say blue, or no, let's say fun color. There we go. So 1/2 is going to be right there. Oop. Probably too big. There we go. There's 1/2 and -1/2. There's my x and y intercept. And then we plot my vertical asymptote and the hole in the graph. So vertical asymptote is at -2. So let's go ahead and plot that. I'll use the red line. Here's my vertical asymptote at -2. And then the hole in the graph is at 2 3/4. So 2 and 0.75. So we'll just put that around there. Okay. And then our vertical asymptote, our horizontal asymptote is at y equals 2. Okay. And that's plotting everything we have found so far. Anybody have any questions yet? All right. Next step is the sign chart. We're going to plot all the x values we have found. All right, so we have -2, +2, and 1/2. Okay. -2, 1/2, and +2. Okay, that's good. Here's my intervals. -infinity to -2. -2 to 1/2. 1/2 to 2. And 2 to infinity. 1, 2, 3, 4. Okay. And then let's pick test numbers. We're going to have 4 test numbers. Okay. Give me a number from -infinity to -2.
-3.
-3. Give me a number from -2 to 1/2.
-1.
-1. 1/2 to 2.
1,
1 and 2 to infinity.
3.
3. Perfect. We're plugging these all into our function. Here we go, Desmos. And we're using the newly reduced function. Where are you? 2x minus 1 over x plus 2. Table feature. And here we go. -3, -1, 1, and 3. So we get 7, -3, 0.33 repeating, and 1. Okay. Now we can fill out the rest of this sign chart. Okay, look at our first output. Is it positive or negative?
The -3 is positive?
Good. So when I say output, just look at the y value.
Yes.
So our first output is positive, which means we are above. What's the next output?
Negative. So we're
Negative.
below.
Below. And what are the next two outputs?
Both positive.
So we're both above.
Oh
All
my
right.
goodness, I've been muted this whole time and I've been answering questions.
My goodness.
I can confirm I have been hearing you.
All right. So now we created points. So our points, actually, I'll write them up there. Why not? Our points are -3, 7, -1, -3, 1 and 0.33, and then 3, 1. All right, let me go ahead and plot those first, and then we'll use our sign chart. All right, I was using fun color. So -3, 7. 1, 2, 3, 4, 5, 6, 7, right there. And then -1, -3, 1, 2, 3, 1 and 0.33, which is right there. And then 3 and 1. Okay. Let me copy and paste this sign chart so we know where to go. No, get off that. Come on, behave. There we go. Okay. So from -infinity to -2, we are above. So from this point, we follow the asymptote up and down to the left. And then from -2 to 1/2, we will start at the x-intercept and follow the vertical asymptote down. And then from 1/2 to 2, we stop at the hole in the graph. And then from 2 to infinity, we begin at the hole in the graph and we stay above. And follow the horizontal asymptote out and to the right. There we go. Actually, I need those points. You stay there. Okay. Cool. And that's graphing a rational function with a hole in the graph. Any questions on that process? Instead, it's a lot of steps, but it's pretty repetitive. And it's stuff we know already. All right. Everybody good with that one?
I believe so.
All right. Okay. Yeehaw. Which brings us to our last one. Construct a rational function from its graph. Okay. So here we're given the rational function or the graph of a rational function, and we want to put it into function form. So one thing to remember is that vertical asymptotes come from your denominator and x-intercepts come from your numerator. So looking at this graph, if I want to put this back into function form, what are my vertical asymptotes?
Cassie in chat answered -5 and 5.
Well, my vertical asymptotes are -5 and 2. There you go. So -5 and 2. So remember, vertical asymptotes come from your denominator. So how would I put these back into linear form or factored form? What would I write?
X plus 5 times x minus 2.
There you go. All right, cool. Well, we're almost done with the vertical asymptotes. Now we want to look at the end behavior of the graph and your vertical asymptotes. Remember, we want to know about the multiplicity. So look at -5. One tail goes to infinity, and the other tail goes to -infinity. This means that the asymptote of x plus 5 would have even or odd multiplicity.
Is that odd?
It would be odd, right? And what is the smallest odd power?
1.
1. So x plus 5 gets a degree of 1. Good. Now, look at the asymptote of x equals 2. And look at the end behavior of your graph. One tail goes to -infinity, and the other tail goes to -infinity. This means that x equals 2 would have what type of multiplicity, even or odd?
Odd.
Even.
Odd, remember, odd meaning one goes to infinity and one goes to negative infinity.
Hmm.
Even means both tails head towards
Both tails
infinity
head towards-
or both tails head towards negative infinity. So
Oh.
what type of multiplicity would it have?
Even.
Even. And what's the smallest even number?
2.
2. All right, guys. Denominator is figured out. Now, let's figure out the numerator. And remember, x-intercepts come from the numerator. Where are my x-intercepts at?
-2 and 5.
Good. -2 and 5. Perfect. Now, how would I put those back into factored form?
X plus 2, x minus 5.
Good. And now, one more thing to look at. Look at the behavior of the graph at these intercepts. Does the graph cross or touch at x equals -2?
Touches.
Which means that -2 has what type of multiplicity?
2.
It would be even,
Even.
which would
Sorry.
be the lowest power of
2.
2. And look at 5. Do we cross or touch?
Cross.
Which means it has
Multiplicity of 1.
multiplicity of 1, an odd multiplicity.
Multiplicity.
Good.
Odd.
So we've covered the vertical asymptotes and we've covered the x-intercepts. The next thing to cover is our horizontal asymptote. Y equals 2. So remember that if we get anything other than 0, what rule are we dealing with? Rule 1 or rule 2? Remember that rule 1 states that the numerator's degree has to be smaller than the denominator, and you'd get a horizontal asymptote of y equals 0.
Cassie answered rule 2.
Rule 2, good. Rule 2 states that the degree of the numerator is equal to the degree of the denominator, and you'd get the leading coefficients over one another. So, since it's rule 2, are the degree or is the degree of the numerator equal to the degree of the denominator? What's the total degree of the numerator?
Total degree would be 2.
2 and
2 and 3.
3. Good. So the degree of the numerator is 3. What's the degree of the denominator?
It's 3.
3. Therefore, the degrees are equal, and this is why we have a horizontal asymptote of 2, which means all we have to do to finish this is put a 2 in front. And there it is. This is one of many functions that could represent this graph. Oh man. And there you go. That is 5.4. And we are done. So If you got questions, of course, stick around. If not, enjoy your weekend and make sure you show all your work on everything you do, please.